And our goal now is to take our dotted lines and distribute them, instance them around, and then animate them so they're falling down. And our very first step is to do the distribute and instance. Now, what we're working with here is essentially two different objects right now. We have our instances, which is our dotted line, and then we have our original plane. If I select my original group input and just hit O, we can now start to view that. So what we're gonna do is now instance this, distribute an instance onto the original grid plane. I'm gonna go ahead and drop in a distribute. And this time, instead of doing distribute points onto volume, we're gonna do distribute points onto faces because we want these to be scattered all over the faces of that grid. So I'll go ahead and auto connect that between there, and then we can see we get our point cloud. And then if we want our instance points to go onto that point cloud, we know we need to do another instance on points, and we're starting to now daisy chain multiple instance on points on top of one another. So we're going to take the result of our dotted line, which is just instances, and plug that into the instance of the distribute points that are on the grid. Now we're getting a lot more than one. And that brings us to step number 2, which is animate on the z-axis. So now we're going to be working after the instance on points in between the final output, and we're going to bring in our set position again, the same set position that we worked with earlier to animate this. And now if I go ahead and start animating this, we know that we want to animate this on the z-axis, right? So we're going to bring in our scene time node, which is what we use to do the animation. I'm going to go over to frame 0 so that we can see what we're doing a little bit, and plug seconds into the offset. So we're offsetting it based off seconds. But we run into an issue really quick here, and that is it's just kind of floating off into space, right? And you can see this, how it's just kind of shooting off. And that is because it's applying that value, this float value, into that three-way vector, right? So they're all just going positive. And what we want to do is have the X and Y values stay at 0 and then the Z value go down. So if we want to split this apart, what we have to do is do a combine XYZ. And what a combine XYZ node does is just takes float values and then turns them into a vector, right? So if I plug vector into offset, we now have the ability to plug in one float value into just the z-axis, which is what we're going to do with our seconds. Now, as I scrub through this, you'll notice that, okay, right now it's going the wrong way. So how do we reverse that? Well, what we need to do is take the seconds and then multiply it by -1. So let's break that down. What do I mean? What do I mean by that? Right now, as this animates, we have 0 seconds, 1 second, 2 seconds, 3 seconds, and 4 seconds, right? But if we take those values and multiply it by a -1, we're going to get a negative version of that value. So -1 is going to be that result. If we take 2 and multiply that by a -1, we're going to end up with a -2, and so on and so forth. If we just multiply any number by -1, it's going to be itself upside down. It's going to be the negative version of that value. So we'll drop in another math node. We'll plug that in between seconds and our Z. We'll switch over to multiply, and then we'll do -1 on that value. And now if I click play, we'll see, okay, now it's going to be dropping down just as we expect. Now, the next problem that we're trying to solve is, they're all uniform. It doesn't feel like raindrops anymore, right? They're all just kind of going together. And part of having this feel like it's rain is that, it's kind of raindrops against the window. Some of them are moving slower and some of them are going to be moving faster. And that brings us to our step number 3, which is to randomize that animation. So ultimately what we want to do is randomize the second value. So I'm going to give myself a little bit more space to work. I'm going to drop in a random value, just like we did before. And I'm going to use that as a way to multiply against the seconds. So I'll drop in another math node, switch this over to multiply, and then throw random value into the value. Now, if I hit play, we'll see, okay, now we're starting to get random offsets in our animation exactly as we would expect. So let's break this down a little bit more. So this random value here is generating a value between 0 and 1. And it's going to do that over whatever data that we have here. And currently we're working with instances. So each of these instances are going to receive a random value. And that random value gets multiplied against seconds. So usually when we work, we have 0 seconds, and then it goes over to 1, 2, and then 3 seconds, so on and so forth. But now, since we're multiplying that by the random value, these values are going to range anywhere from 0 to 3 at this point. by the time it gets to 3 seconds. And the same thing when it gets to 2 seconds, it's going to range from a value of 0 and 2. And then the same thing at 1 second, it's going to be ranged from 0 to 1. So we're just offsetting that in a very randomized way. Now, if we want to have more control over this, say we want more randomization, all we have to do is go up on that maximum value. So I'll set my max value over to 2, and we'll immediately see that we start to get more animation happening there, more exaggeration within that animation. Great, and that's a wrap for that chapter. We'll have the full node network in the cheat sheets below.